So the very first case or the most simple case is there is no reactions. For instance, here there is example for let's assume that this is a wastewater treatment plants, or you can say that this is a source of pollutants. In the specific case here that there is a source that release these pollutants at a constant flow and constant concentrations. So that means you know what's the concentrations of waste and you know what's the rate at which it's being delivered to the river. And also you know that there is an upstream of the river, so that means there is a certain amount of flow coming in. And there is also some amount of contaminants in the upstream. It's a background concentration, so we can call it C up. And most of the time we're interested in what's the pollutant concentration in the downstream. So what's the concentration of pollutants in downstream? And that means we have to calculate based on whatever the information we know right now. So this is the typical examples when this we could call as a source of pollutants, or let's say stormwater. And when it's discharged into river, what's the contaminant concentration in the river? So that's a very typical example. So for that, let's start with the generic mass balance equations, as I said. So again, another example here is no reactions. That means pollutants are not reacting in the systems in water. And then also let's assume this is a steady state. That means this is the constant amount of stormwater is being delivered at certain time. If this is the case, we know that the generic mass balance equation is volume dc over dt of a system would be q c in minus q c out. And then there is a reaction term here, but because there is no reaction, we assume we can call this as 0, or if we write it the way we used to write before, so that would be v dc over dt. Reactions, we know that there is no reaction, so this becomes 0. And because it's a steady state, that means the concentration of pollutants in the system is constant. So that because his system is constant, that means this change in derivative would be also 0. If you do that one, then the equations become very simple one. So that will be q in, c in, minus q out, c out would be 0. What that means is, this is typical mass balance equations where we can say that total mass coming in should be total mass coming out of the system. So this is a mass balance equation for contaminant. What about the mass balance equation for just water? Well, that we know that if we have two streams coming in, the change in volume or the amount of volume that deliver into the system will be combined, and the outflow will be sum of the inflow. So for water, if you do the mass balance equation, just simply take the concentration out. That will be Q in, sum of Q in should be sum of Q out. That's for water. So let me write it properly. Water. So this is a mass balance if you have no reactions and there are multiple streams combined together. For instance, here is an example, and we say that estimate the concentration of one effluent channel in a system. Let's say there are multiple coming in. One, C1, Q2, C2, so another one coming in, Q3, C3. And then there is two going out of the systems in this mixture. So think of it as a pipe mix. So this will be Q4, C4, Q5, C5. If I ask you what is the concentration of C5, and if I gave you everything else given, let's write it that as a These are all given. Green means given. The only thing that's not given is the right one. Then how do you calculate that? Well, based on the mass balance, we know that sum of Q in should be sum of Q out. So that would be, these are the arrow mark getting in, so that's Q in. So you can write QR plus Q2 plus Q3 must be equal to, these are the two leaving the system, 4 plus Q5. So that means we can, if we want to calculate Q5, that we get the number. All the things that's coming into the system minus the one leaving the systems. That will take care of the flow rate. But if you write the concentrations, exactly same equations, except the difference is now there is a concentration term, Q out, C out. So again, let's write that one, Q1, C1 plus Q2, C2 plus Q3, C3 would be Q4, C4 plus Q5, C5. So if you write C5, if you just rearrange every equation, so that will be Q1, C1 plus Q2, C2 plus Q3, C3 minus Q4, C4 divided by Q5. This is, you can calculate, this is how you can calculate the concentration of one and effluents if you know the concentrations and flow rate for the influence or every other channels. So this is, you can use for example, when there are multiple storm water streams coming into a system, into a rivers, and you want to calculate how much change, how much contaminant concentration change in that river because of multiple stream of storm water.